Okay, so on the left-hand side, I've got a line, straight line, and you can see that we could work out the gradient. And the gradient for this line would be delta y, change in height, over change in horizontal distance, delta y, delta x. You might say rise over run. And on the iPad here, I've got gradient of line 1, which is the red length divided by the green length, but that seems pretty obvious. Now what I'm going to do is I'm going to rotate the whole of that line and the triangle by 90 degrees. I'm going to make a perpendicular line. Now, can you convince yourself that the red line has for sure rotated 90 degrees? So the red lines are 90 degrees to each other. The green line has rotated 90 degrees. So the green lines are perpendicular to each other. So wouldn't that mean that the line 1 and line 2 are perpendicular to each other? If you're not too sure, let's put a little point on the intersection. Let's go and measure the angle between line 1 and line 2. And you see it's 90 degrees. So we've come to this really interesting property about perpendicular lines, that for line 1 the gradient is red over green, and for line 2 the gradient is green divided by red. But you can see that one line is positive gradient and the other line has got a negative gradient. So there you go, there's a property of perpendicular lines, and if you took r divided by g, the gradient of line 1, and timesed it by the gradient of line 2, can you see what will happen? You'll be left with negative 1, which is why you often see this m1 times m2 equals to negative 1, where m1 and m2 are the gradients of perpendicular lines.